Dear students, in this session of lecture, we will study the kinetics of the consecutive reaction. So this reaction will consider first order reactions, or this reaction also called as the sequential reaction or simultaneous reaction. So these are the reactions which is proceeding from reactant to product through one or more intermediate stages more than one intermediate. Let us take an example of one consecutive reaction. So this is one reaction A is a reaction which is converting to B and C, and during conversion A to B, this is a K1 and K2 are the rate constant. Example is this dimethyl ether. So dimethyl ether is converting into methane plus formaldehyde. So here rate constant is K1, and when this reactant is converting to product, again CO plus CH4 carbon monoxide or methane, so again we are getting K2. Another example is your ethylene oxide or epoxide. Epoxide is converted to acetaldehyde, and again acetaldehyde converted into methane plus carbon monoxide. So the rate constant are K1, K2 respectively. We can see this radioactive decay. So lead is converted to bismuth and polonium respectively by emitting beta particles. Means their atomic number is increasing, mass number remain constant. So it is a reaction in which the product formed decay further to form new product. So sequential reaction is this reaction. Now let us take a same example, hypothetical example. A is converting to B and B is converting to C, and the rate constants are K1 and K2 respectively. So we will assume that K1 is greater than K2. Here we will assume this is important. We will take different cases when K2 will be greater than K1 or K1 will equal to K2. So now we will take K1 is greater than K2. And one more condition, if K1 is greater than K2, so this reaction becomes fast, this reaction becomes, second sequence becomes slow. So at t equal to 0, the concentration A is, initial concentration A will be maximum, this will be 0 and 0. When t equal to t at any time t, so concentration A will be A, B and C respectively. So B is playing the two role. One is the formation of, and second is the decay. So decay means it is converting to B to C, and formation is converting to A to B. So at one time B will be the maximum, then A and C respectively. We can see from this graph. So we can see from here is the graph. So in this case concentration of A is decreasing, and simultaneously when A decreases B increases, and when B start decaying, so a concentration of C is increasing. So one time what happens, definitely that concentration of B will be the maximum. So at any time t, the concentration of A is always equal to A, concentration A, concentration B and concentration of C respectively. Now we will calculate the rate of formation of each concentration. So rate of formation of A is how much? So dA by dt equal to K1 into A, and we can write this concentration into concentration of A, that is this one, rate of formation of A is equal to A naught into K1 into e to the power minus K1 into by integrating this equation. So B will exist in the sequential reaction provided that the rate of formation of B must be higher than its rate of decay, which is governed by the rate constant of formation or deformation. So from this graph I have written some points. You can see this one also. A dissipates very rapidly than A, and rate of B dissipates very slowly relatively. And if you take K2 for this one, if you take K is greater than K1, then what will happen? The B can be considered as a unstable intermediate, and RDS means rate determined step for the overall reaction would be conversion of A to B. Now a stage of reaction where the rate of formation of B is equal to its rate of decay. This is called as the steady state. Means the rate of disappearance of concentration of A is equal to rate of appearance of concentration of B, which is equal to K1 into A. Similarly, rate of disappearance of B is equal to rate of appearance of concentration of C. So this is equal to K2 into B. So net rate means net rate of formation of B will be how much? So dV by dt equal to K1 into A minus K2 into B. So why it is net rate? Because concentration of A is greater than B. So this is the equation number 3. So here K1 is greater than K2. So that's why this is written. And similarly, we can add the rate of formation of C, that is the dC by dt is equal to K2 into B or K1 into A. This is the fourth equation. Now from equation 3, means from this equation, so K1 is greater than K2. So net rate of formation B is maximum, minimum is not possible. It will be always maximum, minimum not possible, because there will be some formation of B is always take place from A. So hence rate of formation of dV by dt is equal to K1 into A minus K2 into B. This is given. So we can write dV by dt and take this side into this side. So left hand side if you take it, so it become K2 into B, this become K1 into A. And K1 into A, already we know that from previous equation, that is, it is nothing but the K1 into A1 can be written as the initial concentration A, K1 into e to the power minus K1 into T. Now what we will do, multiplying e K2T into both sides. So if you multiply whole equation into e K2, so we will get this equation. See clearly. And this equation is nothing but the differential form. This equation is nothing but differential form of this equation. So we can write this equation into this form, and this equation will be as it is. This equation I have written this side, it is very clearly. So if you derive this equation, so this will go, this is nothing but the in the form of du into v by dx. So du into v by d is written like a u dv by dx. These are two functions. U, so taking out u dv by dx, and again taking v by dv, v into du by dx. So again you can see, if you take out b, so e K2t by into K2, and if you take out e K2, so this is the dv by d. So this is the function of two functions. So this is the mathematical equations. Now again you integrate this equation. So on integrating this equation, so taking the concentration b as 0, and this will be b e to the power K2t. So dt will be written this side. So take whole equation into dt, and a limit will be 0 to t. So you will get this will be b into e K2t, and this will be written as the K1 A naught whole will be written this side, and this will becomes your t, and divided by minus K1 minus K into 2, because we have to differentiate this equation, and plus c. So on integrating we will get this equation. So for this equation, it is just like a dx is equal to x, so we will write directly over here. So this is from the mathematics. Now to remove c, so when you take t equal to 0, so definitely b will equal to 0 initially. So whole b will equal to 0, so you put 0, and t is 0 0, so c will be how much? So c will be written as the 0 means the e to the power 1 equal to 0, so this will be 0, so minus 0 into t. So c will be equal to how much? So K1 into A naught e to the power equal to 1, and this will become minus K1 in minus K2. So c is nothing but the c is equal to K1 into A naught by K1 minus K2. Now putting this value of c in equation 5. So equation 5 we have seen it. This is the equation 5. So we will put this value over here. So what we will get? So we get b e to the power K2 into t is equal to A1 K1 A naught into e to the power minus K1 minus K2 into t divided by minus K1 minus K2 plus this equation. Now we will divide whole equation. We will divide whole equation by this again e to the power K2 t. So on dividing, what we will get? So this is removed. So we will get take out this as a constant value. So this will be at e to the power minus K1 minus K2 into t divided by minus 1 into e to the power K2 t plus 1 by e to the power K2 into t. So this again taken as a common. You can see again further value. So on just this can be written as the e to the power minus K2 into t. So again cancelling this K2 and this K2. This will cancel to each other because this is your plus, this is your minus. So you will the remaining behind will be e to the power minus K1 into t plus e to the power this one value. So now b is equal to K1 into A naught divided by this value K1 minus K2, and this is nothing but the e to the power minus K2t minus, because this is your minus, so this will come this side minus K1 into t. This is your seventh equation. So now we know that initial concentration of A is nothing but the summation of these three concentration at any time t. So this A can be written as this value, and C can be written as the A naught minus A minus B. So you take C this side, so A naught minus A plus B. So A naught is written as it is, and this A is written as the A to the power A naught into e to the power minus K1 into t, and B can be written as this value. So b already we have derived it, so just substitute this value over here. This we can write from 7, equation 7. Now in this case, take a naught as a constant value. So if you take a naught outside, so this becomes your 1, this becomes e to the power minus k1 in t, and minus whole value will be here, taking out a outside. So now you multiply k1 into k2 by this one. So if you multiply this one, this you will get minus e to the power k1 and k2, k1 minus k2, and you write whole equation as it is. This become minus minus become plus, k1 minus k2. So on solving, a naught is outside, so 1 plus this is the minus k1 into e to the power this one value, this one value, this one value. So if you solve it, you will see this and this are same. This is a minus, this is the plus. So you can cancel these two value. So on cancelling, the two value becomes, we can write like in this form: a naught into 1 minus k2 e to the power minus k1 t, and minus k1 e to the power minus k2 t, and this is k2 minus k1. So minus is converted into plus. You can see this plus sign, this is the minus sign. So see carefully. So but this equation what we got from the value of c is not useful in our problems. In our problems we will get the equation only concentration of A and concentration of B. Now we have to find out how much is the concentration of B is maximum. How much? What is the concentration of B? Maximum value. So for maxima or minimum, again we know that differentiation of this is always 0. This is from mathematics. We know that to find the any maximum minima, this will be always equal to 0. Differentiation will be always equal to 0. So now from equation 7, so I have written this equation 7. You can scroll it back and see it. So this is the concentration of B is k1 into a naught divided by k1 minus k2, and this is the e to the power minus k2 into t minus e to the power minus k1 into t. So now if you are differentiating this with respect to t, so this becomes 0. 0 means this is maximum value. So this is outside value, and this you can on differentiating you will get minus k2 into e to the power minus k2 into t minus minus k1 into e to the power minus k1 into t. So this is constant, and now this is constant, and it cannot be 0. This is constant value, and we cannot make it 0. But this whole value we can make it 0. So whole value will be equal to 0. So on solving, if you solve it carefully, so you will get this value followed by k1 by k2 divided by e to the power minus k2 into t by this value. So this is, you take it up. On taking out, you will get this equation. So k1 by k2 will be equal to e to the power k1 minus k2 into t. Now next step is, if you take the logarithm on both sides, so just multiplying by the logarithm. So if you multiply logarithm, so log of k1 by k2 is equal to log of e to the power e. So take with base e. So here it is with base e. You have to take it. So this is natural logarithm k1 by k2. This is natural logarithm e to the power k1 minus k2 into t. So this is equal to natural logarithm k1 by k2 is equal to k1 minus k2 into t, and this is the natural logarithm e. So for natural logarithm e, this is equal to 1. I have written here. And you can see carefully one more thing, that logarithm e to the power k1 minus k2 into t. So if you see carefully, this is the e to the power. So e to the power can be written as the log m to the power n. So n is equal to n log m. So this is coming this side in the product side, and this will come this side. So this is equal to 1. So k1 by k2 is equal to e to the power k1 minus k2 into t maximum. So this is nothing but the t maximum value. Why maximum? Because b is maximum. So t max is the maximum time when the concentration is b maximum. Is written as a natural logarithm k1 by k2 divided by k1 minus k2 respectively. Now we have to find the b maximum value. So b maximum value we have already calculated. So this is the k1 into a naught divided by k1 minus k2 e to the power k2 t max minus e to the power k1 into t max. So this is the t maximum value when t is maximum, only possible when b is become maximum. Now we will substitute this t maximum value over here. So if you substitute the t value, just natural log k1 by k2 divided by k1 minus k2, put this value over here and put this value over here. Now what will happen? Calculate it. So taking e to the power minus k2 minus t max. So if you take this k value, now we will solve this whole value separately. This and this separately. So take this whole value separately over here. Now first calculate this value. So this is nothing but the e k2 into t max value So this can be written as the e to the power minus k2 divided by k minus k2, and this is nothing but the natural logarithm k1 by k2. Okay, so we can write this value e to the power natural logarithm k1 by k2 to the power minus k2 by k1 minus k2. So this is the minus k2 by k1 minus a2. So this is nothing but the natural logarithm m into n. This is natural logarithm m into n. So this we can write as n into log m. This is natural logarithm m into n. So n log m. This you can see here. This is the log m. So we can put whole this into the power as m. So we can write here e n logarithm. This whole value is nothing natural logarithm m into n. So this is n value is converted into this power. So just see carefully both here. This value is this one and this value is this one. So now we can remove, we can write e natural as this will value converted into k1 by k2 to the power minus k2 by k1 minus k2, because e to the power log x, this is natural log x, e to the power log x, this one is equal to x. So whole value is equal to this from the mathematical point of view. Now e to the power k2 max, similarly this is the e to the power k2 in the e max will equal to k2 by k1 into e to k2 by k1 minus k2 respectively. Similarly, if you want to calculate e to the power minus k1 into t max, so we will calculate in similar manner k2 by k1, and instead of k2, this k2 we write k1 by k1 minus k2. So we got the two value, this and this value. We will substitute this value in these two equations. So on substituting we will get again b max is equal to, that is from equation 10, this value, and write the e to the power 2x here, and again k2 by k2, and e to the power minus k1 into t max, this value over here. So these two value is written, this and this. Now we will solve it. So on solving, this is outside, so multiply this into this and multiply this into this. So again taking constant k2 by k1 outside. So if you take constant over here, this becomes your 1, and this is nothing but this becomes your inverse value. So k2 by k1, k1 by k1 by k2, and divided by this value. So this value is going inverse, minus k2 divided by k1 minus k2. So this is common value, and this becomes 1 minus k2 by k1. And if you see, this is the power is equal, since these two values are constant, this will be added up. So k1 minus k2 divided by k1 minus k2. So if you cancelling, it becomes your 1. So this is nothing but the 1 minus k2 upon k1. This is remaining same, just write as it is. So if you see carefully, so this becomes your k1 minus k2 by k1. So this value equal, and this value equal. So this will be cancelled to each other. So on cancelling, you will get finally what? Consideration of b maximum is equal to a naught into k2 by k1 to the power k2 divided by k1 minus 1. This is the maximum value of b. So this is nothing but the ratio of k2 by k1 to the power k2, and this is the k1 minus k2, in which k1 is greater than k2. And t max we already calculated, that is 1 by k1 minus k2 of natural logarithm k1 minus k2. And a we know that a naught into k to the power k1 into t. So three value we have to remember for the calculation of the problem. Now we'll see the different cases of b maximum value. Case 1, when k1 is greater than k2. So b at any time a naught is a naught multiplied by k1 by k2 minus k1, and this is the e to the power k1 minus k2 minus k1 into t minus e to the power minus k2 into t. This way already calculated. So diagram is also given here. So there are 3 times t1, t2 and t2. So if this one, when k1 is greater than k2. So in this case what will happen? K2 will be, k2 minus k1 will be almost equal to minus k1. So this value will be negligible. So if this value is negligible, so we will get value a naught into k1 by k1 minus k2 into t. So this also become this one. So substitute these two value over here. So we will get this value, and b at any time t will be a naught into e to the power minus k2 into t. So at t1, consideration of a will be equal to b to the power consideration of b at t1, and t2 will be consideration of t2 will be consider c at t2, and consider t3 will be consideration of b at t3 will be consider c at t3. You can see from here graph. this is the concentration of T1, this is the concentration of T2, and this is the concentration of T2. We can compare from here and here. Now second case is that when K1 is lesser than, very less than K2, means rate constant K2 is greater than K1. So again this is the value of B1 and consider B at any time. Since the value K2 is very less than K1, so we can write K2 minus K1 is almost equal to K2, and this whole power will be negligible. So concentration of B at any time T is equal to K0 K1 by K2. So this is K1 by K2. So this is K1 is negligible, and instead of this is negligible, so this part is negligible, so it is written K to e to the power minus K1 into T. So we can see the graph here. So when K2 is greater than this, so concentration B is reduced. Again we can see concentration B is maximum, but it is not that much maximum with respect to concentration of A at any time T. So it is almost lesser than and parallel to this time axis. So when T is equal to 0, so B will be also is equal to 0. Almost T is equal to 0, so B will be all 0. When T is become to infinity, so B is become very negligible. Even when the concentration at is 0, it becomes very 0. So we got that consider A, this initial concentration into K1 by K2 to the power e to the power minus K1 into T. So concentration T at any time T, it is this much value. So we can see this into this, we can write in the form of this one. So concentration B at any time T is equal to K1 by K2 to the power concentration A at any time T. So thus at any time the concentration Bt is negligible in this case in comparison to concentration of A at any time T. So its value can be 0 only as T equal to 0 when B was not formed, and as T equal to infinity when concentration A at any time T is equal to 0. Thus in any finite concentration of B is negligible. So the graph appears to be a constant curve. So we can see this constant curve, and this state is called as the steady state. The case number 3, when K is equal to K2. So when K is equal to K2, so we can see the concentration A is decreasing and concentration B is maximum, not like maximum when you take the case number 1, it is lesser one, and concentration C is decreasing. So in this case, this is the case almost equal to K2. Then concentration dA by dt, that rate of formation of A is nothing but the K1 into A. Rate of formation of B will be K1 into A minus K2 into B. And rate of formation of C will be, that is K2 into concentration of B. Now we'll see some numericals. So how much time would be required for the B to reach maximum concentration for the formation? So when A is converted to B to C, K1 K respectively, and K is given, K1 is log 2 by 4, K2 is log 2 by 2, time in minutes. So time maximum, this is the formula, K1 minus K2 into natural log K1 by K2. So when B is maximum, so K1 minus K2 is nothing but the log of 2. You can see this K1, K2, we can K1 minus K2, we can solve this problem. So we'll get this value minus 1 by 4 natural log 2. And K1, K2 nothing, log 2 by 4 into 2 by log 2, we'll get half value. Substitute this value. On substituting, you will get the answer 4 minutes. Second question, A is converted to B, B is converted to C, the half-life is given 10 minutes, 20 minutes. Find the time when the concentration B is maximum. You will get the answer 20 minutes. So just you try yourself. Next numerical, the half-life of lead is 10.6 hours. It undergoes decay to its daughter element. That is this one, and whose half-life is 60.5 minutes. Calculate the time at which the daughter element will have the maximum activity. So lead is converting to bismuth into this one, and again bismuth is converting to polonium. Okay. Calculate the time at which the daughter element will have the maximum activity. So this lead is converted to bismuth, this bismuth converted to polonium. So K1 of lead is, we can write d constant from the first order reaction, log 2 by this much value, this is value, and K2 will get this much value. Now you substitute this value in the formula. T max will be 2.303 T K2 minus K1, this for bismuth, this for lead. So K2 by K1, on solving you will get the answer 227.1 minute. Now polonium 218 mass number So whose half-life is 3.05 minutes. It decays to lead 214, half-life is 2.68 minutes by alpha emission. While lead 214 is a beta emitter, so in an experiment starting with the 1 gram atom of pure polonium 218, how much time would be required for the number of nuclei of lead 214 to reach the maximum concentration? So this is a reaction of the polonium. It is going by releasing alpha and beta particle respectively. So beta particles, what will happen? Atomic number increases, alpha particle atomic number decreases by 2. So in this case, initial concentration of polonium is, and B is how much? The concentration B is the concentration of lead 214. So these are two values. You have to assume this one. So what is the B max? B max is, this is the formula. So when d by dt is equal to 0, one is maximum, then differentiation of this is equal to 0. Then what will happen? We have to use the formula, this one, we have seen it. T max is equal to 1 by Q1 minus K2 into natural log K1 by K2. So K1 is given, natural log 2 by this minute, K2 is given, this is. Substitute the K1 and K2 this is here value and natural log this value. So you will get the answer T maximum for T maximum for this. This is the time which is required for the number of nuclei of lead to reach the maximum concentration. That is nothing but the 4.1 minute.